Well, good morning everyone. Here we are going to look at 2009 question 10 part B. Now I would say the official term for this kind of a question is an absolute dirty bastard. Now looks nice enough as we get into it, but believe me, there is fun to be had. So let's begin to see what we have. Okay, mass upwards, speed u, air resistance per unit mass, and then we are given maximum height and so on. So let's just stop for a second. We've got a little particle that's going upwards, okay, at speed u. There is a force pulling down on it, okay, which is gravity. All right, we're used to that one. And there's another force pulling down. I'll just put it a bit longer here so it doesn't overlap. And this is kV per unit mass. So it's mkv squared. Okay, so those are the two forces going downwards. So what we know, if we go F equals ma, so F, okay, the two forces downwards are mg plus mkv squared. Now we got to be a little bit careful with our units, because really if u is positive, then both of these guys are going down, so they're negative. All right. Now what this means then is if we break that out, F equals m factor of minus g minus kv squared. All right, this section here is acceleration. Now, so once we got that sorted, we can begin to move into what we're a little bit used to. Do be careful of stuff like g. Okay, sometimes we're used to giving things on a horizontal plane where we don't have it, but in this case we couldn't let it go. Now, let's see how we're going to do it. We know that acceleration is dv dt. That's the nice and handy bit. However, if we look at our question, we are given u, and we know there's a constant, and we're also given the maximum height. So we don't have enough to link the time together at the moment. Okay, we get to go to that bundle of joy in the second half of the question. So we need another way to go about it. Now, another way to look at dv dt is we can do this little kind of trick here, where we have dv dx by dx dt, all right, where x is our displacement. And these basically cancel and you get back to dv dt. This here, change in distance with respect to time, is equal to v. So that really equals, I'll just rearrange them here a little bit, dv dt, v dv dt. So this is the relationship we're going to use to link what we know about acceleration with apologies, dv dx. This is what happens when you do it bright and early in the morning. dv dx, of course, because it links our velocity and our displacement. All right. Now that we have that, let's crack into it. Okay. So what we're going to have here is, we know that, just write it down fresh here, v dv dx, which acceleration is minus g minus k v squared. All right. Now we want our v's on this side, really, because that's where dv is, and our x is there. So these guys can come over here. I'm going to bring the minus over here with me. So I'll just put the minus, say v, okay, the minus outside of it. We haven't gone off the screen there. G plus k v squared, dv equals dx. All right. Now, that's fine. We can begin to put all this together. Except you look at this and you realize, oh my God, what's happened? Now, the main thing to remember is what's happened is this is a 2009 paper when integration by substitution was still part of the exam. If you're seeing this now going forwards, you'll see, by the way, this is what this might come out to. Okay, now I'm going to show you how to do it. It's actually not that hard to do, but if you're looking at any of the older questions, you will have this kind of glitch on it. All right, so what we'll do is I'm just going to, well, we leave our minus sign there, so pop this there. Okay, now the way we do this, integration by substitution, it's a very long word, is we let another thing, let's pick another, use a, because we haven't got a anywhere in this one. We often use u, but we already have u as a constant. Let a equal g plus kv squared. All right. Now, so let's see what happens. Well then, if we have straightened things up here a little bit, dA dv, so differentiate a with respect to v. Okay, when we differentiate that, that goes to 0, and that goes to 2kv. All right, just your normal differentiation. We can bring this over, so therefore dA equals 2kv dv. Now, what we'll do is we're going to have to keep this on a little bit of a box across the bottom here. Let's go back and put that into our problem here. So we're going to sub it in. Hence the integration by substitution. So we know that the integration, oh dear, we're losing a pen here. Okay, after many years of trustworthy service, stop the video, I'll be back to you in a second with a different pen. Right, back with a good pen here. So what we're going to do is we're going to start subbing things in here. So first of all, we're going to sub in, okay, I'll just actually write out the original one so we can see where we're going to go. So there is v over g plus kv squared dv. This bit here is going to be a. So we have integration of a. All right. Now, whereas I'm quite finished here, we'll have to just go and move one little bit over here. We'll use the 2k dA equals v dv. All right, I know that because I can see there's a v dv up here. So if I just want 1 over a, and we take v dv and sub it in for dA, which means I've got to put in 1 over 2k here and keep my minus sign. So that's what this now goes to. All right, that equals, put this down here, we will indeed, minus 1 over 2k because they're constants, natural log of a. All right, plus c. We won't worry about the c because it'll drop out afterwards. And then we sub back. So we end up with 1 over 2k, natural log of a is g plus kv, kv squared. All right, plus c. So that is how we get from this guy here and differentiate it. Now, if you're given this in a modern question, often we just told that's what it is. But if you're looking at the older questions, it's useful to know, and it's not super hard to do. Okay, so we're going to bring ourselves all the way back up here, and what we found up with the x on this side is that, I'll keep it on one side actually, minus 1 over 2k natural log g plus kv squared with some limits we'll find in a second, and dx just goes to x with certain limits. Okay, so what are our limits? Well, if we look at this one here, it's projected upwards of speed u, so when x is 0, the speed is u. So we'll put this one down here. Okay, maximum height is then 4 over 2k, and the speed at the maximum height, well, what's going to happen to the maximum height? Think back to question 1, it's going to be 0. All right, now we're talking a little bit ugly, but hey, if you think this is ugly, wait till part 2. Minus 1 over 2k, natural log of g plus 0, minus, so plus 1 over 2k, natural log of g plus ku squared equals natural log of 4 over 2k. Okay, so that little bit of sin of hope is we do see a lot of 2k's underneath. So this is sort of peak ugliness for this one. It's going to get better soon. Now, whenever I'm dealing with these logs, I like to get them as the plus and then minus, because then you can use your log rules. So we'll put 1 over 2k over here, and that is a natural log of g plus ku squared minus natural log of g. Okay, now all the time you want to be keeping a little bit of an eye on your minus signs to make sure these are right. So yes, I had a plus there, I had a minus there, all is good. And minus natural log of 4 over 2k. At this point, case and cancel. Combine these two. So we get the natural log of g plus ku squared over g equals the natural log of 4. Now at this point, we can actually the terms inside have to be the same. So therefore, g plus ku squared over g equals 4. Bring the g across. We're going to get a little bit tight for space here, so see can we squeeze all this in. So what I'm going to do is I'm going to do 2 in one go if you don't mind. I'm going to bring the g across here, so that equals 4g minus g, and I'll bring that across. So 2 in 1, I always say don't do that, but just for today we'll do it if we don't mind. And that means that u squared equals 3g over k. So therefore u, that's what we're looking for, equals square root of 3g over k. Okay, so that is our u in terms of k. That's part 1. Now, let's have a bit of fun. Part 2. So pop this one out of the way here. Okay. Part 2. What we're looking here is k if the greatest height is pi over 3 seconds. Now, you might think, what a weird time of seconds, but what I'm thinking when I see pi over 3 is I'm thinking trigonometric relations. So this is just a little bit of a warning flag that might go off my head, and we'll look at this later on. Okay, so I want time and height. Okay, how am we going to begin to put this one together? All right, so the way we can relate height is we know at the maximum height, we know the velocity is going to be 0, so we can actually relate v and t, which sort of makes sense because it's the one we haven't done so far. So if we go back to our original idea that a equals dv dt, let's see what we can do with this one. All right, and that is, of course, minus g plus kv squared. kv squared. All right, so a little bit of rearrangement like before. We'll bring this guy over this side, so we will have minus 1 over g plus kv squared dv equals dt. Now, put our minus sign outside of that. Let's have a little think about how to integrate this. And as we look at this, okay, this looks weird, this looks difficult, okay? So what we're going to have to do, and if you try to arrange integration by substitution, you'll end up down a sad, sorry road because you won't get the v on top to deal with. So we need to see, what else does this ring a bell on? Well, what this is beginning to ring a bell is the idea that 1 over a squared plus x squared dx equals 1 over a tan inverse x over a. Now that is one of the little relationships that is in your log tables. I would say no, it is there. You may memorize it, but even know it's there. The big thing is I'm seeing this 1 over something squared in the bottom. It's not right on this side yet, so I'm going to have to make this look like that. All right. And what we're going to do is we're going to divide everything by k. So now when I say everything, I mean really everything. So we are going to end up with 1 over k all over g over k plus v squared. Okay, and we still have a minus on the outside. Don't forget that, a little bit of fun. dv, and that's just equal to t. Okay, now in this case, a equals the square root of g over k. Didn't I say this was going to get fun? Yes, indeed. All right, now it just looks ugly, but it's a case of punching it all in together. So now that we know what we're doing, and again, the trick with this one would be to move that 1 over k outside. All right, so I'll just do that as a bit of a line. We end up with minus 1 over k, 1 over, okay, g over k plus v squared dv equals dt. That's what we're looking at. Okay, put it down there. Now, let's talk about limits. What do we know about this thing here? So I should flick back myself to the question. We want the time reached the greatest height is pi over 3. So let's see what we have here. Time, let's call this the greatest height. So at the greatest height is, of course, going to 0. And that's pi over 3. Do we know anything else? Well, at time 0, we know our speed is u. Okay, and we already know u from the last part of the question, so that's probably what we're going to have to do to solve. let's go for it. Okay, now minus 1 over k, put that outside. All of this here, all right, is going to be 1 over a, which was 1 over the square root of g over k, tan inverse v over the square root of g over k. Working off limits of 0 and u. Now, before you get too freaked out and you're wondering this is going horribly wrong, remember u is something to do with the square root of g over k. So this is probably going to come back together on us. It is going to come back together on us. And that's, of course, t at the limits pi over 3 and 0. Off we go. Now, our minus is going to be nice, it's going to drop out on us, so that is going to end up being tan inverse of 0. So, let's see. Oh, I'll let my calculator. Apologies. Pause the video for a second. Okay, got the calculator. And the reason I want to show you this one is just if you ever get stuck on these ones, you can't remember the slightly more unusual ones, just tan inverse 0, check it dead quickly. Okay, so that is all going to end up being 0 minus k, so we're into plus 1 over k. All right, 1 over root of g over k, so we'll bring those together in a little moment. Tan inverse, and what we're going to get here is u over square root of g over k, and that is equal to pi over 3 minus 0. Right, let's do our housekeeping. Now, what can we do here? This is going to be 1 over k square root of g over k. Now, if you want to just break that one out, we'll see we break that out just over here. That is, so k by the root of g over k is square root of k squared g over k, which is square root of kg. Okay, so we'll get that in the next time around. Tan inverse. Now let's sub in u here. So we know that u is square root of 3g over k all over square root of g over k. That's pi over 3. Okay, now this is about as ugly as you'll get in these, certainly as ugly as I've seen in a long time. So what do we have here? We have the root of 1 over square root of kg. All right, in hindsight I'd write that as gk, just in case you're thinking we're working in units. What about this one here? Okay, do a little breakout on this one. Root 3g over k is really root 3 root g over k all over root g over k. Bump, bump. So that's just root 3. All right, now it's getting nicer. Tan inverse root 3 equals pi over 3. Okie dokie. Now just remind ourselves what we're looking to find. We are looking to find k, is that right? Fabulous. Okay, so at this stage, this is getting kind of weird and messy. So now I would just stop and try and find a relationship here. So I'll say, well, look, how are these two related? Okay, we don't worry about that for the moment. Let's see, can we begin to see that one? So if we go tan inverse square root of 3 all right, we're going to get pi over 3. So you begin to realize that these two equal each other. All right, and this is the key. You can kind of poke around in different ways, but that is our connection here. So what we can say is that 1 over root kg equals 1, which is divided by pi over 3, or tan inverse root 3 on each side. This is a little bit nicer. 1 equals square root of kg. Square them. 1 equals kg. I'm running off the page here yet. So you can see here that k equals 1 over g. Nice and elegant. And there you have it. That was an absolute dirty bastard, but it's a fabulous way to practice all your different integration and differentiation skills.